Students, in this video I will go over exercise U6A01B, where I will be applying concepts of radian measures of angles. These exercises that you see here in this assignment are taken straight out of the Regents, ranging from 2014 all the way up through, let me see here, all the way up through 2018. I guess 2019 did not have a question related to this topic. Okay, so question number 18 from 2014 sampler says, in the diagram below, the circle shown has radius of 10, angle B intercepts an arc with a length of 2 pi. What is the measure of angle B in radians? So this is straight up, do you remember this formula? So the arc length is equal to theta r, where theta is in radians. So right now, you have 2 pi is the arc length. Theta, which we don't know, r is 10. All you got to do is just divide both sides by 10, and theta will end up being pi over 5. This is the angle measure in radians. In the diagram below, circle O, the area of the shaded region of sector is 12 pi inches squared. Find the length of OA, and the length of OA is 6, not find the length of OA. Determine and state angle AOC. So in this problem, it didn't state like what form to leave the answer in, whether it be in degrees or radians, because this question is not a multiple choice question. So if you remember the area of a sector formula in radians, it's simply 1/2 theta r squared. So in this case here, since the area is 12 pi and the radius is 6, so 1/2 theta 6 squared is equal to 12 pi. So therefore, I end up with 18 theta is equal to 12 pi, or theta is equal to 12 pi over 18, or simply theta is equal to 2 pi over 3. You'll actually end up with a very similar answer if you were working in degrees. You'll end up with 120 degrees. I guess I'll go over that as well, just to show you how sometimes working in radians is way simpler, okay? So anyway, we don't know what theta is, so let's say we work with this formula, theta over 360 times pi r squared, right? And this is equivalent to 12 pi. So if you go through this, you notice that the pi's cancel. We're left with theta r squared over 360. So if I multiply both sides by 360, I'll end up with theta, and substitute what r is, right? So theta times 6 squared over 360 is equal to 12. And notice that 36 over 360 becomes theta over 10. And this is equal to 12. So theta is equal to 120. So 120 degrees, are these two things actually the same things? As a matter of fact, it is, because if you convert from degrees to radians, 120 degrees times pi over 180, this does in fact equal to 2 pi over 3. So they are actually the same things. Alright, but as you can see, this process over here on the right is way simpler, in my opinion. Okay. Number 29, June 2016. In the diagram below, circle 1 has radius 4, with circle 2, and circle 2 has radius of 6.5. Angle A intercepts an arc, length of pi, and the other one is 13 pi over 8. Okay. Dominic thinks that angles A and B have the same radian measure. State whether Dominic is correct or not. Explain why. So, A, so circle 1 here, S is equal to theta r, right? Or AR. So angle A is equal to pi over 4, in other words. Over here, I have 16.5. So 13 pi over 8 is equal to B times R, which is 6.5. So if I take and divide this, B is equal to 13 pi divided by 8 divided by 6.5. Let's see if that actually comes out to be the same thing. What's 13/8 divided by 6.5? If I take my calculator, 13 divided by 8 divided by 6.5 is 0.25. That's a quarter. So in other words, 1/4 pi. So yes, Dominic is right. So A equals to B. Dominic is right. Okay. In circle O, diameter AB, chord BC, and radius OC are drawn, and the measure of arc BC is 108. It's on the other page. So this is 108. Okay. Some students wrote these formulas to find the area of sector COB. So COB. To find the area of sector COB. So 3/10 times pi times BC squared. 108 over 360 times pi times OC squared, and so on and so forth. What is the question here? What is the question? I'm gonna guess which one is the correct one. So the correct one would be 108 over 360 times pi times OC squared. This is the only one that is correct. Only correct one. Why are the other ones not correct? Well, that's because this doesn't make any sense, because pi times 1/2 r squared, that's the semicircle, area of a semicircle. This guy over here is a quarter of a circle, and this guy over here, BC, that's not anything. BC is a chord, not a radius. So that's the only one that's correct. January 2017, in the diagram below of circle O, GO is equal to 8, GOJ is equal to 60 degrees. What is the area in terms of pi of the shaded region? So what's left over here is 300 degrees. So 300 degrees over 360 times pi times r squared times 8 squared. And what would that reduce to? That would be the equivalent of 30 over 36, which is 10 over 12, which is equivalent to 5 over 5/6. It's 5/6 pi times 64. And then that would be equivalent to 5 times pi times 32. 5 times 32 is 160. So it's this thing right here. Alright. In a circle with diameter of 32, the area of sector is 512 pi over 3. The measure of the angle of the sector in radians is, so again, S is equal to theta r. So this is a sector, not an arc length. So 1/2 theta r squared is equal to 5/12 thirds pi. Okay? and the diameter is 32, which means the radius is going to be 16. So it's 1/2 theta times 16 squared is equal to 5/12 over 3 pi. So what is this? This is going to be 1024 over 3 times 16 squared pi, which is some ugly, ugly, ugly number. So 1024, I'm going to take my calculator, divided by 3 times 16 squared, which is that, and fraction is 1 1/3, so it's going to be 4/3. So theta is equal to 4/3 pi, which is this guy right here. In the diagram below, the circle has a radius of 25 inches. The area of the unshaded sector is 500 pi. Hold on. So of the unshaded is 500 pi. Determine the degree measure of angle Q, the central angle of the shaded sector. So if that's 500 pi and that radius is 25, so I know that the 1/2 theta times 25 squared gives me, will allow me to find out what the angle is in radian measure. So this is equivalent to 1000 pi over 25 squared. So 1000 over 25 squared, what is that? 1000 divided by 25 squared. That is equivalent to 8/5. 8/5 pi. And so to figure out what is angle Q, I am going to subtract this from 2 pi because 2 pi is a full circle. And what I'm going to be left with is 2 pi, 2/5 pi. Because 10 pi minus 8 pi is 2, right? I'm left with 2/5 pi. And I need to convert this into a degree measure, so angle Q, therefore, is going to be equal to, I'm going to multiply 2/5 pi by 180 and divide by pi. So 2/5 times, so 2 times 180 divided by 5. 2/5 is 72. So angle Q is 72 degrees. Alright, 22. The diagram below shows circle O with radii OA, OB. The measure of angle AOB is 120 degrees, and the length of the radius is 6 inches. Which expression represents the length of arc AB in inches? The length of arc AB in inches. So arc AB will be 120 over 360 times 2 pi times 6. So this is equivalent to 1/3 times 2 pi times 6, or this is equivalent to 4 pi, in other words. Which expression represents the length of arc AB in inches? So looks like they didn't even reduce. So let me see here. That would be this guy right there, because 1/3 of 12 pi is 4 pi. Okay. Number 28. In the diagram below, circle O has a radius of 10. AB is equal to 72. Arc AB is equal to 72. That means this guy over here is also 72 degrees. Find the area of the shaded sector. So 72 degrees over 360 times pi times 10 squared. So 72 over 360 is actually 1/5 times 100. So that would be 20 pi then. And is that it? That is it.